Hey everybody, Mr. Bowman here. This video is going over the Year 9 practice exam in preparation for the 2025 end of year exams. So what I've got there is this here is literally what the front cover looks like. Your front cover will be the exact same, except it'll have the date instead of that practice exam. It's going to have the 4 parts, part A, part P, C and D, and then there's the room for the extension score there as well. Clicking over to the next slide, you can see this formula sheet here. You got resource 1. It's got all the key formulas you're going to need. You're not going to need too many because most of the maths will be without the formulas. And then finally, it's got your geometric reasoning in resource 2. Both of these you can utilize at any point throughout your exam. It'll be there printed with you. So let's get into the numeracy section. So that's section number A with 20% of your overall grade. And really important, you can see down below the heading there, instructions on the timing for this section. I've given you some recommendations on how you should spend each of your time. And basically, if it's worth 1%, you should be worth it spending 1 minute on it. So this 20% section, you should be aiming to spend 20 minutes on. So don't go overboard. Don't spend more than your 20 minutes on this because you'll find you'll run out of time and maybe completely miss the last section. Okay, so before we start doing the math in section A, I want to quickly talk you through some of the questions so you can see them. So these ones here are a bit different. So these are going to be really important practice questions for your numeracy exam next year in year 10. And you can see some of the questions say learning outcome 1. You know, those two there say learning outcome 1. And then some there say learning outcome 2. You've got learning outcome 2 up there as well. And if I flip over to the next slide, you can see this one here says learning outcome 3. And the rest of the learning outcome 3 ones kind of form later on in your exam there and there as well. So to pass the numeracy section in your year 10 exam, you need to be showing 3 different skills: learning outcome 1, learning outcome 2, learning outcome 3. And you need to get half of each of the learning outcomes. So that's what we're expecting you to do here as well. So to be specific, you're going to have learning outcome 1, learning outcome 2, learning outcome 3. In our exam, the practice one and the real one, there's going to be 4 of each. And to pass, you need to be getting 2 of each of the learning outcomes. So that's going to be really important. I think we've set, if you get 3 of each of the learning outcomes, you're going to get merit. And if you're getting, all of each of the questions, you can kind of get into the excellent stuff. But you've got to be showing a range of skills in relation to each of the 3 learning outcomes. So let's get straight into question number 1 of your practice exam. And there's 2 ways to do this one. I'll talk you through both of them. So we've got a box of calculators weighs 2.16 kilograms. If the calculators collectively weigh 180 grams, how much does the box weigh? So the main trick of this question is you've got different units. So it's testing on your measurement units here. So you could be dealing in kilograms. That could be one way to approach this question. So if you're dealing in kilograms, you're going to go the 2.16, which is the combined box weight, and you're going to go minus 1.8. Because if we divide the 1,800 by 1,000, that gets you to 1.8 kilograms. If you do that, that there will give you a weight of 0.36 kilograms. Alternatively, I'll write or over here. If you did work in grams, that's 100% okay as well. You'll need to times your kilograms by 1,000. So that would tell you it's 2,160 kilograms. You'd minus the 1,800 kilograms. So not kilograms, grams that we've got, and that there would get you to 360 grams. So either of those would get you full marks. So let's move on to question number 2. We've got if 5 adult tickets to a concert cost this much here, how much would 8 tickets cost? So for these types of questions, it's really important is I try to standardize this, and that basically means finding the price of 1 adult ticket, or one bus ride, or 1 gram of deli meat, well, whatever the question is. So standardize it to 1. So the way we're going to do that is we're going to go 437.50. That's the total cost for the 5 tickets. We're going to divide it by 5. And that tells you what 1 is. And in this case here, it's 87.5. Now that you've standardized it, so it's 87.5 per ticket, we can just multiply it by what we're looking for. And in this case, we're looking for 8. So that means 8 adult tickets. That's going to be 87.5, and I'm timesing that by my 8, and my total price here is going to be $700. So learning outcome 1 done, learning outcome 2 done. We're going to get a few more done. So let's look into question number 3. So Extra data added on most phone bills are at a fixed rate. So if you go over your data charge, they then charge you for every MB or every bit of data that you use. Matua Jordan is looking at his bill, but he can't figure out how much the extra data is used. So he can't figure out this used data amount. Calculate the MB used by Matua Jordan. So normally the way the charges work is you'll do the amount used times by the rate, and that there will be equal to the charge. In this case here, we're kind of working backwards. So in our algebra, when we work backwards, we do division. So this number here divided by this number here will get you the missing number here. So we're going to do our opposite to help us figure this out. So we're going to go on our calculator, it's going to be 76.11. We're going to divide that by 0.59. And when I did that earlier, and hopefully you're getting the same answer as me, I got 129 MB. And just noting, I'm putting in my units there, MB. Had my dollar signs over here, had my grams and kilograms over there, so those units are really important. So now into question number 4. We've got deli sells shaved ham at this much per kilogram. How much would 250 grams of the shaved ham cost? So there's two ways to do it. We can do it through the standardizing method we did earlier, or we could use some proportions. I'll run you through both. So I guess the first thing to note is let's figure out what 1 gram costs. And then we can multiply by our 250 to find our bigger number. So 1 gram would be 37.60 divided by 1,000. And when I did that, it's a bit of a weird number, and I'm not going to round it here because I need to use this number later. I got basically $0 and 3.76 cents. So it's a bit of a weird number. Now that I've got that, I can then use that number to find out the total weight. That's the 250 grams. 250 grams, and it's going to be that number there, 0.0376. Forgot the decimal point there, and that's going to be multiplied by the 250 gram weight of the deli shaved ham, and that there gets us to $9.40. So $9.40. So that was actually the more complicated way to do this question. I'll do an or here because it was an easy way to do this. So some of you might have noted that 250 grams is 1/4 of a kilogram. So what you could have actually done is you could have divided that by 4. So 37.6 divided by 4 to find 1/4, to find 250 grams, and that would have got you to the same answer. So both methods will get you full marks. Obviously this one here is easier, but it relies on it being exactly 1/4. If you didn't have 1/4, maybe if that was a funnier number, you would have had to do like more of a standardizing approach where you find the cost of 1 gram and then you ramp it up to the grams you've been required to get. Okay, now to question number 5, which is on the beginning of the next column of the page. And I've left my answer from question 4 at the top there because it's a little bit relevant here. And I want to note it's the first learning outcome 3 question. And there's a specific approach that I want you to take for your learning outcome 3s, because they're the harder ones. If you're gonna miss out on this section of the numeracy exam, most of you will be missing out because of learning outcome 3. But the process I want you to follow, it's 3 steps. First step, you need to do your maths. So you need to process the numbers. There might not actually be any maths to do. It might just be pulling out numbers from a graph, or it might actually be an actual calculation. Just depends on the question. Once you've done your math, you need to talk about your math. So talk about your numbers. And then number 3 is where people forget, and often it's the easiest part of this process, is clearly answering the question. So clearly answer the question. And I'll show you this 3-step process with each of the learning outcome 3 questions that we're going to look at in this particular video. So this here carries on from the deli shaved ham kind of theme that we had from question 4. So an alternate to the shaved ham in question 4 is a 300 gram pack that costs $11.50. Is it better value to buy the shaved ham at the deli rate or in the pack? So basically what we're trying to find here is we're trying to find a standardized weight, and then we're going to compare which one's cheaper. So just from my knowledge of kind of deli sections and how they work, normally they sell them per 100 grams. So what I'm going to look to do is I'm going to look to find the deli cost, which is going to be per 100 grams, and then I'm going to compare the same with the the packaged price per 100 grams as well. So the deli price is going to be pretty crazy. So it's going to be the 37.6 from before. So we've got 37.6. We're going to divide that by 10. That means it's going to cost us $3.76 per 100 grams. We're then going to do the same with the pack price. So we're going to find the dollar price per 100 grams. And when we do that, the 100 grams is going to be a little bit different in terms of approach. We can see it there, 300 grams is $11.50. So this $11.50, if we divide it by 3, that will give us 100 gram amounts. You could have also done the divide by 300 times by 100 approach as well, but we don't need to do that here as well. 11.3 divided by 3, and that there did get us a funny number, so we had to consider rounding here, but I rounded that to $3.83. So that's your first part. Part number 1, we've done the math. Part number 2, we now need to talk about the numbers. So we just need to explain what the numbers mean in context. So that's what we're going to do next. I'll do a little bullet point to show that. So we're just going to talk about the numbers. So deli meat, so deli shaved ham costs $3.76 per 100 grams. And packet or pack shaved ham costs $3.83 per 100 grams. So notice I haven't answered the question there. I was literally just explaining what those two numbers were there. So that's the second part of answering a learning outcome 3 question. And the final part down the bottom there, forgive me, is that play button. That pause play button kind of sits in that area, so it makes writing down there a little bit annoying, is clearly answering the question. So the question says, is it better value to buy shaved ham at the deli rate or the pack rate? So when you're answering the question, you should try to use words from the question. So they've used the phrase better value. So I want to include that phrase. Better value needs to go into my response there. So I'll start by saying that. So it is better value to buy shaved ham. I'll just leave a bit of a gap there to avoid the pause button. At the deli rate. And then maybe in brackets, I'll just substantiate that. And in this case here, it was 0.07 per 100 grams cheaper. Okay, so hopefully you can see how this learning outcome 3 process works. Your 3 steps for learning outcome 3. And if you do that, you'll find you'll be getting most of the marks, unless you do a math error or interpret the stuff wrong. That's probably the only trip up you can get if you do follow that process correctly. Okay, we've got question number 6 now. We're back to learning outcome 2. These ones are a bit nicer. They're the more difficult math ones, but often a bit nicer. So there are approximately 2,800 boys at our school. 55% of them take part of the cross country. 1/4 of the students who took part of the cross country were year 11. So we've got a whole lot of numbers there. How many students took part of the cross country who were from year 11s? So we're trying to find out how many year 11s were part of the cross country. So what we're going to do is we're going to start off by doing 2,800 times by 0.55. So this here is going to tell us, well, what is 55% of the entire 2,800? And that'll tell us how many people are actually doing the cross country. So in this case here, it's going to be 1,540 people are doing the cross country. Now that we've got that number, we're going to divide it by 4 to find the 1/4 who are from the year 11. So we're going to go 1,540. We're going to divide that by 4, get that 1/4, and that there is going to be 385. And I'm just going to explain what that means. So 385 year 11s who are doing the cross country. Okay, now moving on to question 7, and we're back onto learning outcome 1. And if I didn't say it before, learning outcome 1 is all about just really pulling information out from a question, maybe only doing a small calculation, but there's not much calculation to it, but it's pulling out the information. So below is a timetable for the Hobsonville Beach Haven City Ferry. Kerry needs to reach downtown by 10 a.m. if he's catching it from Beach Haven, so he's leaving from Beach Haven, trying to get to downtown at 10, and then we got what's the latest ferry he can catch. The way I'll be starting this one here is just going to read my headings. So this here is departing downtown, going to Hobsonville, then going to Beach Haven, back to Hobsonville, and then arriving back in downtown. So it looks like it's doing a bit of a loop, and then I assume these ones here kind of line up with these ones here. Maybe there's a bit of a wait time in between. So he's trying to arrive in downtown. So we're looking at this thing here. We need to find the number that is immediately before 10 a.m. because anything after 10 a.m. means he's late. So looking down that list, we can see 11:35, that one there. That one's too late. So any of these ones here are gone, which means he needs to arrive on this 9:35 ferry to be there at 10. And this makes a bit of sense because it gives him about 25 minutes to, arrive wherever. It's unlikely he needs to be at the ferry building at 10. He's probably going to an office building or meeting a friend somewhere else, whatever. Following that backwards, so we're catching this 9:35 one from Beach Haven. So follow backwards there. That means he needs to be catching this 9 o'clock ferry at the Beach Haven. So I'm just going to put that in a short sentence. So Kerry should catch the 9:00 ferry from Beach Haven. Okay, we're down to question number 8, and this graph here shows the height of FIFA players from the 2018 World Cup by their position. They haven't told you the exact positions, but they've given you some details there. What was the height of the tallest player? So we can see the scale here. This is our height one here. So we're looking for the player that's biggest on this, and we can see a purple dot or pink dot over here, and that there's kind of sitting in between the 6'8" and 6'6" range. So that there probably means the tallest player is going to have a height of 6'7", right? So 6 dash, that's what 6 foot means, and then 7 inches, that's what the dash means there. So question number 9, we've got something about a school fundraiser. They're selling reusable drink bottles for $12 each. Each bottle costs $7.50 to buy. So the difference there would probably be your profit margin, right? That's the profit you're going to make towards the fundraiser. The organizers also spent $45 on fundraising, also not fundraising, on advertising, and it makes sense. You normally got to advertise and promote your event, and they've got 60 bottles to sell by the looks of it. Calculate how much profit they're going to make and explain whether the fundraiser will meet their goal of at least $200. So just a reminder, this is a learning outcome 3 question, so it's going to be a similar process. So it's going to be number 1, do your math, and that's going to be a bit heavy for this question compared to the previous one. Number 2 was talk about your numbers, so just explain what the number is. And then step number 3, it was to clearly answer the question. So let's go through and break that down. So we've already done the math there. We already know the difference between the $12 and the $7.50. That's going to be how much profit we make per bottle. So the starting of our maths is going to be $12 minus $7.50. That's my profit per bottle. And I need to multiply that by 60 because I've got 60 bottles here. And when I do all of that, I'm getting a profit an income of $270. Now, the issue is from that income, they've gone ahead and they've spent $45 already. So once we've done that, we're going to go 270 minus my $45 of advertising expenses, and that gets me $225 of profit. Now, this number here is larger than the 200 number, so it looks like their goal is going to work. However, it's a bit tight. It's $25 off is not that bad, and it really does rely on the big assumption of selling $60. So most fundraisers, you normally get a few things left over here and there, but on the face of it, it looks like you're going to make enough money. If you wanted to argue there's going to be some leftovers and they might not be able to make the full $200, that will probably be an acceptable argument too, but we'll run with that one there. So that's our step number 1. We've done the math. Step number 2, we're going to talk about the maths. So I'll state if they sell all 60 bottles, they will make a profit of $225. Okay, so that's step number 2 done. And remember, that's just me talking about the number I've calculated. It has nothing to do with a question yet. I haven't answered that question. It's just me stating a fact about what it is. And then the third one, this is us answering the question. Basically, do we think they're going to earn at least $200? And in this case, yes, we think they do. So the school fundraiser, or rather the students, will likely meet their fundraising goal. Got that I there. Fundraising goal of $200 of profit. That's the final part of the puzzle. Learning outcome 3, I've clearly answered the question. So a reminder for learning outcome 3, you've got to follow this 3-step process, do the math, explain your numbers, and then clearly answer the question. So we're now on to question number 10 up here. Estimate the length of the wooden car, and it's learning outcome 2 because you're trying to find out, something to do with the proportion of a whole. So that's what makes it a learning outcome 2. And this one here, we really are estimating. So what you could do is if you had your ruler, you could measure that distance and measure that distance there and do some division to come up with that number. So you could be quite precise about it, or you could kind of eyeball it like I'm going to do here. So if you kind of, draw a green line at the back of that car there, roughly come up with the same distance. So that distance will probably be the same as that distance there. So I reckon it's not quite a third. So a third of this would be 5 centimeters. I think the car is slightly bigger than the 5 centimeter number. I'm going to go with 6 centimeters for my prediction. 6 centimeters. And just a note, if you did think it was a third and said 5 centimeters, you probably would be getting full marks for that because it's an estimating question. They will allow for a bit of variation. But I didn't write that one. I'm going to go with 6. I think it's slightly more than a third. Okay, we're on to question number 11, and this is again a learning outcome 3 question. So you need that 3-step process going on. So we've got 1, 2, and number 3. So Harry's looking at buying a VR set and a racing wheel. He's looked at 2 places to see who offers the best deal. We've got information on the deals over here. So Shop A sells the VR for $550, the wheel for $380, but it's got a 20% store-wide sale. That looks pretty good, 20% off. Shop B sells the VR for $570, the wheel for $395, but it's got buy 2 items and get the cheapest half price deal. So 2 different deals. What we're going to need to do is we're going to need to do the math for both of them to figure out the combined price. Once we've got that, we can then get into step 2. We can just explain what the numbers are, and then we can get into step 3. We can answer the question about who's cheaper and where Harry should go. So let's do the math first. So I suppose let's just do a Shop A, Shop B type working. So Shop A, we know it's going to be these 2 numbers here, 550 and 380. We're going to add them up to find what the total would be before the sale. So we've got 550, 380, and then once we've done that, we're going to times it by 0.8. And remember, 0.8 is like 100% minusing the 20%. So it's the 80% remaining that you've got to pay. And when I plugged that into my calculator, I got $744. I'm now going to repeat the same for shop number B. Let's see what their total is. The working is going to be different, remember? So shop number B. So the cheaper one is half price. So that means we're going to be paying the full price for their VR set. So we're going to be paying $570, and we're going to be adding on the price of the wheel, which is going to be half off because you're getting the cheapest of the items half price. So that there is going to be 395 times by 1/2. Hopefully you know how the times halves work on your calculator. If you don't, confirm that with your teacher prior to your exam. When you plug that into your calculator, I'm getting a price of $767.50. So that's step number 1 done. I've done the math. I'm now going to move on to explaining what the numbers actually mean part. So we're just going to say the wheel or both items will cost this much from shop A and this much from shop B. So let's get into that. So both items will cost $744 from shop B. Oh, sorry, that's from shop A. And $767.50 from shop B. So let's get shop B down there. Okay, from shop B. And then, so that's your step number 2. You've just explained what the numbers mean, and you'll be glad to know in the exam you'll get a bit more room than what I've been given here. And then finally, we go ahead and answer the question. So what shop should Harry buy it from? I'm going to clearly state that. So Harry should buy the VR and wheel from shop A. And then in brackets, I'm just going to state how much it's cheaper. So if we subtract this number from this number, it's $23.50. So I'm just going to write it's $23.50 cheaper. And that there wrapped up our answer. And again, that was the third step. Step number 3, clearly answering the question. Okay, let's get on to question 12. This is the final question, also a learning outcome 3 question. So remember, we need to follow that same 3-step process. But step number 1, let's do the math. So the graph tells us the total income of the 4 main streaming services. So we've got Netflix, Disney Plus, Max. I've never actually heard or watched that one there. And then Paramount Plus. They must be American type ones. One commentator said Netflix accounts for about half of the total income from streaming platforms. Do you agree with this claim? So we can see the income generated from each of the platforms there. They're claiming that Netflix is about half. So keyword, it says about. It didn't say precisely half, exactly half. It says about. So it could be a little bit over, it could be a little bit under, but that'll be all sweet there. So let's start by doing the math. Let's find the total income would probably be my first one. So total income, if I add all these together there, it's going to be 283, which is Netflix, 154, Disney Plus, 103, Max, whatever that is, and then Paramount Plus. I have heard of that. I've never seen it though. 68 there. So the total income for all of these is going to be 608 million. So 608 million. We're trying to find out Netflix's proportion of that. So there's a few ways you could do this. You could go ahead and calculate the percentage, or you could just compare the numbers. Both will get you full marks. So let's do the percentage approach just because it's the harder one. So if we go 283 divided by 608 times it by 100, this is going to give us the percentage of the total share of income that Netflix has. And when I did that, I got 47%. That had a 0 DP rounding. So that was a rounded up number. And we can see that number there is pretty close to 50%, right, which is a half. So based on that, the commentator is probably good. Alternatively, you could have gone, well, 608 total divided by 2 is 304, and that there is pretty close to the 283 million that Netflix have. So you could have just compared the proportions instead of doing a percentage calc. I won't stress about that one too much, but you would get full marks with that approach as well. So that there is step number 1, right? We've done the maths. Step number 2, we now want to just explain what that number means. So our math relied on the number 47. So let's explain what that number means. So this means Netflix has about 47% of all streaming income from the 4 main streaming platforms. From the 4 main streaming platforms. Okay, so that there was learning outcome, step number 3. And then finally, that there was step number 2. I've just talked about what my 47% was, and now I can answer the question, do you agree or disagree with the claim? So based on this, so as 47% is near 1/2, I agree with the commentator's claim. Commentator's claim. There we go, and that wraps up the numeracy section from this exam. And just a reminder, we had learning outcome 1, learning outcome 2, learning outcome 3. You needed to get 2 of each of the learning outcomes to pass, and that there would be the equivalent or showing us or suggesting to us that you've got, the core skills that you're going to need to approach next year's Year 10 Numeracy exam. So we're now into section B. This is the geometry and right angle triangle section. It's worth 20% of the overall grade, which means you should be spending 20 minutes on it. Just a reminder, it's a risky game to go over your 20 minutes because it means you might miss entire sections instead of part of sections. So try to stick to those times really thoroughly. So let's get into question number 1. It's multi-choice questions as usual to start off with. What type of triangle is the below? And just a quick recap, there's, I suppose, all the different triangles we've got. We've got a right angle triangle. That's easy enough. That's a triangle with some kind of right angle in it, which we don't have any here, so it's not going to be that one there. So we'll cross out right. An equilateral triangle, that's when all 3 sides and all 3 angles are the same. That's actually the one that we've got here. So the answer here is going to be an equilateral triangle. But just to continue recapping, an isosceles triangle, that's one when maybe you've got 2 of the 3 sides are the same. And then finally a scalene triangle, that's when all 3 sides have a different length, or the angles are all different, one of the 2. But in our case here, we've got an equilateral triangle because they're all the same. So question number 2, which of the following options completes the sentence below? Internal angles of a triangle sum 2. And hopefully this is a nice one that you feel confident with, 180 degrees. So we can circle that there. No need to read the other options. Also in your geometric reasoning section of the exam, so if you need to look back at those to support your answer, to confirm your reasoning, you can do during the exam. Question number 3, triangle ABC has been transformed. So triangle ABC is this one here. That means it's been moved or recreated to form the other triangle, which is A-B-C-. What transformation has taken place? So we can probably eliminate a few of them. So we know it's not reflection, right? Because if it was reflection, it would kind of be looking like this here. So we know it's not that one there. It's not been enlarged. Translation. So translation is just moving something left or right, up and down. So you can kind of see the triangles should be pointing the same direction if it's translation. So I know that's not the one I've got here. So it's not translation. Therefore, it has to be rotation. And we can see that graph there, it looks like it's been rotated 90 degrees this way here to create the new section. So we're now moving on to question number 4, which describes the movement from point A to point B. So because we're just moving up and down, left and right, reminder, this type of transformation is called translation. And that's when things just move. So in our case here, we can see if we go directly down, it's being moved down 3. And then from there, it's being moved right by 1 unit. It could go in either order, so it's not down 2. So it is B in this case here because it's been right 1, down 3. And we know it's not up, and we know, so those last 2 are both up. So we know it can't be either of those ones there. So now into question number 5. Angle P is 128 degrees. So they've actually given us the answer here. So it's 128 degrees. Which of the following is the best geometric reasoning to support the answer there? Or a bit of formatting issues there. That should have been up there, but that's no stress. Basically, this is the straight line rule, right? Because we can see a straight line popping up here. So that means all 3 angles, so this angle here, this angle here, this angle here, all 3 of those are kind of sitting within the straight line. That means they've got a sum to 180 degrees. So angles at a triangle, it's not that top one there, so it is going to be B. And we know it's not angles around a point, and we know it's not vertically opposite. So definitely B in this case. And then number 6, this one here is actually an achieve question, which is quite nice for the multi-choice areas. So the 2 angles below are labeled M and N. So we've got M and N. We can see those in the diagram. What type of angles are they? So I guess the first thing to note straight away, I know they're not corresponding angles because that's not a parallel line angle rule. And we can see we've got 2 parallel lines here, and we're trying to figure out which of those parallel line rules apply. So I suppose to recap them, co-interior angles, they both sit in the parallel lines. So both in the parallel lines, which is actually what we've got here, right? So you can see you've got your parallel line there. Both of those angles are kind of sitting within them. So it's one of those ones there, but I also want to note alternate angles also both sit in the parallel line. So we know it's not corresponding because corresponding is when you got like one here and one here. So you've got one in and one out. So it's got to be A or C. Alternate angles, they are ones where they're on different sides. So this line coming in the other direction, that's the bisecting line. Alternate angles are when you've got one on each side. So if we had an angle here and an angle down there on the bottom, those are on different sides of the bisecting line, so they're alternate angles. We don't have that one there, which means it's got to be co-interior angles, and that's because they're sitting within the same area, the same side of that bisecting line, and they're both inside the parallel lines as well. So moving on to question number 7 and 8. These all follow the diagram that we're given here, though. So I suppose the question is, we know that lines 1 and 2 are parallel, so that line there and that line there are parallel lines, and that's always given away by the little arrow that sits on the parallel lines at times. Calculate the angles below, include your geometric reasoning. So I suppose before we chat about this one here, let's talk about the marking schedule. So this could be developing or achieved. If you state your reasoning, that's kind of the expectation of a Year 9 student. So, and if you are able to calculate the angle but can't figure out why, that's kind of a developing type mark. So that means you're pretty close to the curriculum, but you haven't quite refined those skills that we're looking for. So let's do angle number A first, and angle A is a nice one. You can see angle A over here, and we can see that is kind of opposite the 42 degrees there. So that means angle A has to be 42 degrees. You now need your reasoning, and remember you've got your reasoning sheet that you can always refer to, but the reason in this case, it's the vertically opposite angle rule, right? So vertically opposite angles are equal. So again, you don't need to memorize this because they're on your sheet, but you do need to explain why those two are angles. So those two are equal. What's the relationship between A and 42 degrees? So now moving on to angle B down the bottom there, and this one here, I'm just going to draw a green line here. So I can see angle B and angle 115, they're sitting on that same line. So both of those must combine to the 180 degree straight line rule. So the working for this one here, it's going to be 180 minus the 115, which I've got, is equal to 65 degrees. So that's my angle for B, and my reasoning, angles on a straight line sum to 180. Sum to 180 degrees. And the last one there, angle C, that's the one sitting down the bottom. And if you put the previous two answers in, we know that's 42 degrees there. We know that's 65 degrees there. And C, it's looking pretty easy there, right? Because that's the third angle inside the triangle, which means that's got to sum to 180 degrees. So whatever C is, it must combine with the other two angles to get to 180. So what we're going to do is, because I'm using the 180 triangle rule, I'm going to go 180 minus 42 minus 65. And when I put those together, that gets me to 73 degrees. And I'm using my triangle rule. So internal angles of a triangle sum to 180 degrees. And just to note, there were 3 parts here, so this practice exam is a bit rough. You needed to get all 3 with reasoning to get your developing mark. If you missed some reasoning or maybe got one reasoning wrong, you'll probably get that developing mark. It means you're close to the curriculum, but not quite there. And then number 8 is what's up next. So calculate angle D, and it specifically says using parallel line angle rules, and that's what makes this a merit question, because this is kicking in to the new geometry that comes up in the Year 9 and Year 10 curriculums. So angle D is here, and for me, there's 2 ways you could approach this one. So I'll go through both angles, or both ones, so both answers. So we've got our parallel line here, parallel line here. We've got our bisecting line this way here. We can see D and 65. They are alternate angles, right? We've got both inside the train tracks, like we talked about for that multi-choice question, and you've got one on either side of the bisecting line. So we know alternate angles, they are equal to each other. So you could go straight to 65 degrees. So you could go 65 degrees, and that's because alternate angles in parallel lines, and noting I'm being really specific about them being in parallel lines, are equal. So I'm going to write that there. I'm now going to write or, give you an alternate answer. The other way you could have done this one is angle D here and angle 115. They are co-interior. That was the previous multi-choice question skill. So we know both of those have to be summing to 180. So what we could do is we could do 180 minus 115 instead. And again, that is also 65 because it makes sense, right? I should be able to get to the same answer regardless of the approach. And I can state my co-interior reasoning as well. So we've got co-interior angles in parallel lines are equal. So either of those with that geometric reasoning will get you the merit mark. If you got the angle right of 65, because it's a high level skill, you would have got the achieve mark without the reasoning. But obviously, I think it would be a shame to miss out on that merit mark if you didn't get that full reason to support that. So we're now on to question number 9. And basically, the question's been really spelled out for us. Use Pythagoras' theory to answer the questions. And that's questions 9, 10, and 11. So same skills. So hopefully you're confident with Pythagoras' theory because it's coming up big time in your exam. So let's calculate y first. And the way I taught my classes, and your class might have been different, is so because we're trying to find one of the short sides here, we need to subtract these two squares. So we're going to do 27 squared minus 23 squared. So we've done the subtraction part, and we then also need to square root it to find the square that would have sit on that side y. And when I put that into my calculator, I get 14.14 meters. So I'm putting in my units, and I'm stating my rounding of 2 decimal points. So now moving on to question number 10. Question number 10, you can see it there, calculate z. We're now trying to find the long side of this triangle. And when you're doing the long side, you are adding together the squares of the two short sides. So that's going to become 70 squared plus 24 squared. And then don't forget, we always got to square root these to find out the actual length. And then when I do that, we get a nice whole number this time around, 74 centimeters exactly. And then finally, question number 11. And this one here's a merit one because there's 2 steps. So we're trying to find out x here. But to find out x, you needed to know this length here and then this length here. But we don't actually know that diagonal one. We don't know that yet. So we're going to need to use the bottom triangle to figure out the missing one. So we're going to use this triangle here to find out the missing one. And then once I've got the missing one, I can then find out the information needed for that top triangle. So let's do that bottom one first. So let's call this one y actually. Let's carry on with that x and y theme. So doing y first, we're trying to find the long side of this triangle. So it's going to be a plussing of the square scenario. So we need to go 3 squared plus 4 squared. If you square root that, that gets you to 5 centimeters. So we now know that y is 5. And same thing again, we've got the 2 short sides. We're finding out the long side here. So again, it's the same thing. I need to add together my squares to find that answer. So x is now going to be equal to 5 squared plus 12 squared, square rooting that. I put that on my calculator before, and I got 13 centimeters. So that one there was a nice, fairly straightforward one, but back-to-back, I suppose back-to-back Pythagoras' theory questions. Really important that you have that skill down and you know the difference between calculating a short side and a long side type question. So we're now on to question number 12, and this is a contextual question. So the maths isn't going to be that tricky here, but because we've got words surrounding it, and it hasn't told us exactly what to figure out. Like if you look at this diagram, we can't see an X or a letter anywhere. So what are we trying to figure out? That's when the words need to be broken down, and you need to do that yourself. So we've got a 2.9 meter ladder is leaning up against the wall. So that's going to be this length over here, right? So that's 2.9. That's confirmed by the number there. The base being 1.3 meters away from the wall. Oh, sorry, not from the wall, from the wall. So that's telling us the base of that ladder is 1.3 meters away from the wall. Not, I keep saying wall, but wall. How far does the ladder reach up the wall? And that's asking you to figure out that height there. So by breaking down the question, we can figure it out. So let's call that x. Trying to figure out x. So we're trying to find, that looks like a short side question. So that means I'm going to be subtracting my 2 squares here. So let's get that subtraction happening. So I need to do 2.9 squared. So let's jot that down. 2.9 squared minus 1.3 squared, and I need to square root it. Doing all that, I'm going to get the answer. I'm getting 2.6 meters when I put that into my calculator. Again, I've rounded this. Your rounding might be slightly different, which is all good. But as long as it's pretty close to 2.6, you're going to be all sweet. Because this is a wordy question and it's a merit question, I might just want to explain what my answer is in terms of the ladder reaching up the wall. So I'm just going to put my final answer in a bit of a sentence. So the ladder reaches 2.6 meters up the wall. Okay, so now on to question number 13, talking about the spinner here. And we've been asked, oh, it's a regular pentagon, so that's a nice hint. So that tells us there's 5 equal sides. And it also tells us that inside of it, there's going to be 5 equal angles as well. So that's some useful information for us. Show your working in geometric reasoning. Oh, so we're calculating x. So I suppose the information I've identified here, 5 equal sides, is not going to be too relevant to this question. But do note that because that's going to be relevant to some questions coming up, maybe in your exam. So I guess the key thing to note is we're trying to find x, and that sits within triangle, that yellow triangle number 4. And if you think about it, this here is the middle of the shape. And if you go from the edge towards x and the edge towards the other corner, those two sides here and here, those are going to be equal to each other. So we've actually got an isosceles triangle. So that means this angle here is also going to be x. So what that actually means is we just need to figure out this top angle here to then use our isosceles triangle rule. And the nice thing about that top angle there is that's going to be the same as this angle here, this angle here, this angle here, and this angle here, because all of them are joined together equally around that point. So what we're going to do is to find this top angle up here, we're going to go 360 divided by 5, and that there is going to be equal to, have I got the maths right? It's not 72, is it? Oh, it is 72 degrees. I've got it right the first time. And the reasoning behind that is angles around a point sum to 360 degrees. So that's my reasoning. Angles around a point sum to 360 degrees. So I've got that point there. Now that I've got that point there, if I go 180 minus 72, that's going to tell me how many angles are left over to be the base angles that's shared between the x's. And because there's 2 equal angles, I'm going to chop that in half and divide it by 2. And when I do that, I get 102 minus 72, sorry, 108 minus 72 is 108. 108 divided by 2 is 54 degrees. So that means angle x is equal to 54 degrees because, and the last one we need to justify too, that's because the base angles of an isosceles triangle are equal. So base angles of an isosceles triangle are equal to each other. Okay, and I suppose the moment of truth, I imagine a lot of people are interested in waiting for this one here. The 2 excellence questions coming up now, 14 and 15. So let's do 14 first. Basically, we've got a spinner, so similar theme to that question number 13, the previous one we just did. This time around, it's a regular hexagon, so that means there's 6 things. Don't be confused by this 8. We've tried to trick you there. It's not 8 sides there. There's definitely only 6. It's even told you it's made up of 6 equilateral triangles. So these triangles here are all equilateral triangles. And don't forget, they've got their own properties in terms of all of the angles are 60 degrees. So all angles equal 60 degrees. And all sides are equal to each other as well. So that property we might be able to use to solve this problem. We've also been told each side of the hexagon is 5, so that side there is 5, but that also means all of these internal lines are 5, 5, 5, 5, 5 as well, because all of the sides are equal, as we mentioned before, and we've been asked to calculate the area of the spinner. So it seems like a pretty rough question, a pretty difficult question, but let's just focus on one triangle because we've got 6 triangles. So if we can figure out one triangle, we can then just times it by 6 to get the other triangles. So let's sketch out triangle number 8. Let's draw a nice big one so we can work with it a bit easier. So that's triangle number 8. And the issue we've got here is we don't have any right angle triangles. So to find the sides of the triangles with the skills we've learned about Pythagoras' theory, and we know it only applies to right angle triangles. which we don't have because all of these are going to be 60 degrees, aren't they? Because it's an equilateral triangle. But what we can do, this is called construction. We're going to add in a line. So if I chopped my triangle in half, that was a poorly drawn line. If I chop it in half this way here, I'm going to have two right angles down the bottom there. Both of these would represent half of the equilateral triangle, but they'll, more importantly, they'll both be right angle triangles. So we're going to do our trigonometry. So let's draw a right angle here. Also, not trigonometry, Pythag. So we already know that each side of the triangle is 5. So I know that this side of my triangle here must be 5. The issue is, because I'm dealing with a smaller triangle, this smaller half base is going to be the part of the triangle we need. And because it's half of the base, we know that there is actually going to be 2.5. And don't forget, these are all centimeters. So that means we can figure out the height of this triangle. And the height's going to be really, really important because to find the area of the triangle, you've got to do base times height. So you can't go like 5 times 5 because this 5 up here on the diagonal, that's not the base and it's not the height. So you'll get the wrong answer by doing that. So we're going to need to use Pythagoras' theory to find out that vertical height cutting down the middle. So this height side of the triangle down here, that's a short side of the triangle. So it's going to be a subtraction type question. So h is going to be equal to, so it's going to be 5 squared, which is my long side, minus 2.5 squared, which is my short side, and I need to square root that. When I do that square rooting, I get 4.33, and the units here are centimeters, which had a 2 dp rounding. Now that I've got that, I can find the area of one triangle. Don't forget that's area equals 1/2 of base times height. So let's jot that down. So area of one triangle is going to be 1/2 times by base times by height. Plug in those numbers in, so it's going to be 1/2 times the base. So remember, the base is still the full 5, not just the short 2.5. So times 5 times my height, that's the up and down that I've just calculated at 4.33. So 4.33. And when I plugged that into my calculator, I got 10.825 centimeters squared, and I haven't bothered with any rounding there. I've just kind of left it as it is. The next part of the question is timesing it by 6, because I've only found the 8 triangle here. I've only found this one down here. I need to go times 3, times 4, times 5, times 6 to get all the 6 triangles summed together. So let's jot that down. So area of the hexagon, which is all of the sides, is equal to 10.825 times by 6, and that gets me to 64.95 centimeters squared. So that wraps up that first excellence question. Pretty rough question, and the key to it was the idea of construction. That's you adding in a line to help you make the right angle triangle or help you make something else to then get to the rest of the question. So final question, maybe the hardest of them, but actually quite easy once you know what you're doing. Question number 15. Form an expression in terms of x and y. So I just want to know what that means. So an expression means your answer is going to be a bit of algebra, and there's going to be some x's and y's in your algebra. So we're not going to be able to say the answer is 20 degrees. We're going to be able to say it's something to do with x and y. So that's our end goal. We're trying to find the angle IJH. So let's find that angle. So I is over here, J is over here, H is over here. So we're trying to find the angle. If we connect that line there. So we're trying to find this angle here. And we've got some x's and y's up here. So basically these x's and y's are going to need to flow their way through the diagram and end up down here somewhere. And that will be our end expression. And then as usual, because it's geometry, support your answers with geometric reasoning. So this question here, as I said, it's easy if you know what you're doing, difficult if you don't. So the first thing to note, or the first thing I'm going to do anyway, is I'm going to move this x over here. And that's because they're vertically opposite angles, so they're always going to be equal to each other. So let's write that down first. So what's my angle there called? So this angle here is called angle EKI. So we've got EKI. So I'm going to go angle EKI is going to be equal to x degrees, whatever that is. And that's because vertically opposite angles are equal to each other. So that's the first step there. The next thing that we're going to do, and this is going to be where kind of the next level stuff comes into play. The other thing I need to note is the angle we're dealing with here is actually going to be equal to this angle here, this combined bigger angle. And that's because they're corresponding angles. So let's jot that down. So angle EKJ should be equal to angle, the one we're trying to calculate, angle IJH. And that's because corresponding angles in parallel lines are equal. So corresponding angles in parallel lines are equal. Okay, so we haven't answered the question, so the only thing then we need to do is we need to answer the question. So angle IJH is going to be equal to these two angles here, and that's going to be x plus y, isn't it? So our answer there is going to be x plus y, and that's what I said earlier. Our final answer will be some kind of algebra to do with x and y, and in this case, x plus y. So nothing horrifically complicated there for that last question, but being able to flow algebra through your geometric question is quite a challenging skill, and that's what made it an excellence one there. Okay, so we're now into section number 3. That's the stats section, and this section's another important one, and of note, it's worth 20%, which means you should be aiming to spend 20 minutes on it. Again, be really strict with your time. Don't go over it. If you follow the timeline I've set out, you should have 20 minutes left over at the end to go back and touch up on some questions you might have skipped ahead. But don't just miss out on entire sections because you spent 40 minutes on a 20-minute section or whatever it might be. So question number 1, let's get straight into it. Stats and probability. How many face cards are there in a standard pack of cards? So I guess to note, the face cards are the cards that literally have a face on it. So it's going to be Jack, Queen, and King. They're the only face cards. And in a pack of cards, there are 4 of each, aren't there? 1 of each suit. That means there are 12 face cards in total. So it's not these ones here. That means it's got to be C, number 12. So now into question number 2. So a teacher has asked their 9 Math class about their favorite movie types, and that explains this. We've got sci-fi, drama, romance, comedy, action, all the good stuff there. The results are displayed in the graph below. What percentage of students preferred comedy or action? So when you see the word or, it normally means you've got to add together the probabilities. So I need to find the probability of comedy, which is going to be this 20% up here. So it's going to be 20%. Then you've got the comedy of the percentage of action, which is going to be over there, and they combine to get to 45%. Hopefully one of those is the option, and that's option D down the bottom there. Question number 3. A lot of students don't really like questions like these, but they're important. What is the probability of the bus crashing the next time you catch it? So you need to think about likelihood. So 0 and 1 are the obvious ones to start off with. So probability of 0 means it's impossible to happen. And that's not going to be the case with buses, right? Buses crash. They're unlikely to crash, but they do happen. And it's possible that you're on it, which means it's not an impossible event. A probability of 1, that means it's something that's guaranteed to happen. And bus crashes, well, hopefully they're not guaranteed to happen if you're on them. But yeah, they don't happen all the time, so it's not guaranteed. C is the next one. This is a really common probability. That's a 50-50. And that's not going to be the case as well. And the answer here is 0. How many zeros is that? 0.00001. So that means it's a number, which means it could happen. But because it's such a small number, it means it's really unlikely to happen. And I think I used AI to help me generate that number. I think it was about 1 in a million type shot of you being on the bus when it crashes. Okay, so we're now moving on to question number 4, which best describes the median. So obviously understanding your definitions, mean, median, mode, range, integral range, all that sort of stuff is really important. So there'll always be one of those in there for you. And it's actually the first answer there. I don't need to read much. So the median, if you've got your data listed in order, the median is always the value that sits in the middle. And it even says that in order, middle value. So it's definitely going to be A. Let's talk about the other ones, so see why it's not. So B, the difference between the highest and lowest. It's not that one there because the difference between the highest and the lowest is the range. The value that occurs the most often, definitely not that one there. That's the mode. And then the average of all the values, that's what we call the mean. So none of those ones there. So getting into the next lot of questions. The last last two multi-choice questions. Question number 5, which best describes the long-term trend of gas prices? We can see the gas prices are here, and when you're asked to explore the long-term trend, all you need to do is look at the last point, look at the end point. What's happened in between doesn't matter. Basically, if we connect that with a line, does it go up or down? In this case, it goes up. So we know it's not changing, we know it's not decreasing, we know it's not negative. The only thing to figure out is, well, what's the exact word I need to use? Is it positive or is it increasing? And time series is all about increasing and decreasing. So that means C is the right answer. It's not positive. Positive is your TARSOG language, which applies to scatter plots, but not your time series graphs here. So don't use positive, negative when you're talking about time series graphs. And then the following one here, which best describes the relationship between a person's height and a person's weight? So this one here is an achieved one here because it's actually quite difficult. So the first thing you need to think of is, if you were comparing a person's height and weight, what type of graph would it be? It's not a time series graph, right? Because there's no time as one of the variables. It's not going to be a box and whisker graph, which means it had to be a scatter graph that I mentioned before. So you'd probably have height along here, and you'd probably have weight up here. So it's one of those graphs we're going to have lots of dots kind of looking around like that. The next part of it, and what makes it so difficult, is you've got to kind of critically think about the two variables. So what's going to happen with these variables? So, for example, as you're aging through high school, you're getting a lot taller, right? And as you get taller, your weight goes up. So as you get taller, your weight goes up. So your data, your line of best fit's probably going to look like the line I just drew there, right? So as you grow, your weight is going up and up and up and up. So that means, as I said before, time series is all about increasing and decreasing. So I know it's not the last two. I can rubbish those ones. It's got to be positive or negative. In this case, it's positive because as one goes up, the other goes up with it. We're now moving on to question number 7, and technically this was from the previous page, page 8, but I've just dumped it here because it related to questions 7 and 8. So we've got a community in the United States prides itself in its donut eating competition, and where I got this graph from, it actually did suggest that this was actually real data that they collected, so I thought that was fun. After reviewing their historical data from 2005 to 2010, the data is a bit old. Organizers have created these box and whisker graphs to compare the two events. And we can see the county fair down there and the city exhibition there. And what the donuts are doing, it's comparing the number of donuts eaten by competitors in the event. And they've kind of found, you've got the median sitting in the middle, you've got the lower quartile and upper quartile there and there, you've got the minimum and the maximum, and they've chopped it up into their quarters. So question 7, calculate the range for both of the events. So this one, the range by itself is probably a developing mark because it's a pretty easy skill, but because you've been asked to do both of them, that 2 calculations back to back, and reading the numbers off the graph, which is a skill in itself, probably pushes it up to achieved. So let's do the county fair first. So county fair, remember you're doing maximum minus minimum. So if I'm estimating going down, that looks like it's going to be a maximum of 40. Down here, it's in between 4 and 6. That's going to be 5. So that's going to be a maximum of 40 minus a minimum of 5, which means the county fair range is going to be 35. I'm now going to repeat that for the city exhibition. Don't quite know what that is. I can picture a county fair, but don't know what the exhibition would look like. So repeating the same thing. My exhibition, that looks like, 37. Down there looks like 10. So we've got a maximum of 37 minus our minimum of 10. That there is equal to 27. So having both of those there is how you're going to get that achieved mark. So moving on to question number 8, we've been asked to compare the median number of donuts for each of them. I talked about this before. The median is the middle values. So if we have a look down here, so we've got a median of, that looks like 18 up there for the county fair. And then we've got a median of 20 for the city exhibition. So by looking at them, we can see the median of the city exhibition is larger than the median of the county fair. So I now just need to put that in my sentences. And remember, the questions down the bottom here normally tell you exactly what to write. So it says your answer should be in context, and it should include evidence from the graph. And of note, it says the word compare. So we can't just state the numbers. I can't just say the median of this one is 18, the median of this one is 20, done. There's no comparison. So a word like higher smaller, bigger, heavier. Some kind of comparative word like that is really important to get your full marks. So let's start off with my first sentence. Let's just start off with my comparative statement. It's a really easy thing to write. So I'm just going to say the median. So the median number of donuts eaten in the, we'll do the biggest one first, the city exhibition is larger than the median number of donuts from the county fair. Number of donuts eaten in the county fair. Okay, so I've got that part there. So that's the comparative statement part. So I've done that tick there. The last bit there, I need that evidence from the graph. So what makes me think they're larger? And that's when I can actually pull out the numbers and provide evidence. So in this case, it's 2 larger. So I really need to sell a story that talks about 20 and 18, and I'm comparing them together. So it is larger. And notice that there's my comparative word from the previous comment. So it is larger as the median at the city exhibition is 20 and the median at the county fair is 18, which is 2 larger. So that there would be your evidence, and that would wrap up locking that merit marker that hopefully you're aiming for. Okay, so we're now on to question number 9. This is a big wordy one, so I'm just going to type up my answer instead of handwriting it just to save a bit of time and hopefully get through it a bit quicker. But the question we've got here is we've got a time series graph below. You can see I'll put that square box in there, so I've blanked out what the sales actually are. And you can see what's happening over time. And the key thing to note is this product, which we don't know, it's unknown, it's sold in New Zealand, and simply the question is, what do you think the unknown product is? And specifically, it's told you what's a thing. It's asked you to use statistical observations. It's asked you to use evidence from the graph, and it's asked you to use context of the unknown product to justify your answer. So there's 3 things I'm kind of looking to do here. The first thing to note is we are doing time series here. So you need to think, well, what are the skills relevant to time series? And the first thing is its long-term trend. Is it increasing or decreasing? That by itself isn't going to be too helpful for the question because lots of products go up, lots of products go down by sales. I've got no idea how that's going to help me get an answer. But the seasonality part of it, you can see it goes up and down, up and down, up and down as time goes on. That seasonality part might suggest something about the product. So we're going to use a discussion of the seasonality, the peaks and the troughs, to hopefully come up with some nice conclusion about that. So before I start the question, I'm just going to think about my structure. So I'm going to do one sentence as a bit of an intro, because this is an e-question, so I want to do well. I then want to do one sentence discussing the peaks. I want to do one sentence discussing the troughs. And then finally, I want to wrap up and come up with some kind of conclusion. So it's probably going to be, maybe 6 to 8 sentences, depending on how much I spend on each of them. So let's do a bit of an intro. So I'm talking about the weight of sales, and I'm going to maybe suggest that it depends on the season or the time of the year. So the weight of sales of the unknown product may be dependent on the season/time of the year. And that's really just setting the tone for the rest of my discussion. So because the sales may depend on the time of the year, that means seasonality is important, hence why it makes sense for me to start breaking down the seasonality of it. So let's talk about peaks first. So I suppose we can see not much information at the beginning of the graph because I can't really see what's happened before it, but the first peak and up and down happens in quarter 1. And repeating the same, we see it goes up and down. The very peak up there is still quarter one as well. So I can see both of the years I'm seeing, 2015, 2016, I'm seeing a peak that's happening in quarter one. So that's the first thing I'm going to mention. So I can see that our data peaks in quarter one in both 2015 and 2016. So I can now talk about those. These are my statistical statements, by the way, statistical observations of what's happening, what I'm doing here. So I've used numbers from my graph. I've got, quarter, or I should write quarter one. Quarter one. So quarter one is evidence from the graph. I've got the years 15 and 16. That's some more evidence from the graph. I can now talk about the troughs. And we can see quarter two down there is pretty low, quarter two down there is pretty low, and yet again up there, quarter two is low. So I can see there's a clear trough every quarter two. So I can also see that our data is at its lowest point each year. Oh, whoops, I forgot. Each year during quarter two. We see this in all 3 years on our graph. So again, I've got more evidence from there. So I now need to start thinking about my overall thought. So I'm seeing something, it's quarter one. We can maybe add a comment here. Quarter one is when it's hot. It's New Zealand summer. Maybe it's the beginning of the school year. Maybe that has something to do. So quarter one is quarter one because it's the first 3 months of a year. 3 months being a quarter. So quarter one is January, or forgive the bad spelling, February, and March. These months are warmer than the others and are during the holidays and beginning of the school year. So I was thinking, so obviously during the holidays, during the warmer months, that gives you, it could be a summary type item. And obviously beginning of the school year, maybe this is stationery related or school supplies type stuff. Obviously important to do that as well. So quarter two being a trough is a bit interesting. So we'll probably think about adding in some context there. But let's wrap into the conclusion and try to bring in that trough part of it as well. So I'm now going to start talking about what I'm thinking. I'm thinking about the summer stuff. So I think the sales of the unknown item must be linked to the season and temperature. Sales are at their highest in quarter one, and I should note quarter four as well, because if you can see the next highest point, quarter four was happening here. That's still pretty high compared to 1 and 2 here. And up the top here, you got quarter one here, but quarter four was quite high, again, compared to your 2 and 3. So quarter four was quite high as well, and that's the other side of summer, right? Because December's officially when summer kicks in. So that certainly wraps up that. And then I suppose I should note the opposite, and at their lowest. So sales are going to be at their lowest in quarter two and quarter three. So let's make our final statement, I suppose. So the unknown product. So let's actually answer the question. So the unknown product is likely something commonly connected and used in summer, such as, I'm going with ice cream. Sunblock might be a good one. Or maybe swimwear, something like that. Or in sunwear, swimwear, etc. So I think those are some really good suggestions, and they match the seasonality, the important part of that graph that I'm trying to demonstrate there. Okay, now onto questions 10 to 14, and these all relate to two-way tables, and two-way tables tends to be one of the better done sections of every exam. So hopefully it's one you're confident with, because that way you're going to stack up all the easy marks. I suppose the first thing to note is the context of the question. The Warriors have had 117 games from 2021 to 2025. Part of that overlaps with the confusing COVID days where some home games were over in Australia. Some Australian teams then paid that back by having home games in New Zealand. It was a bit weird, so the numbers don't line up perfectly like you'd expect, but let's get into it. I suppose the first step of any two-way table question is to fill out the table. So normally what you have is you'll have either information to populate the table, or you'll have a partially completed table which you'll fully complete. So let's start fully completing this. So I know the home total is going to be here, and that's going to be the sum of these two numbers here. That's going to be 63. Now that I've got 63, I can calculate this number here, because 117 minus 63 is going to be that number sitting in the middle there. And when I calculated that earlier today, I got 54. Same thing with this number here. I can do that with subtraction. So 54 minus 22, that's 32. So I've got 32 there. I can now add those up to get to 64. So 64. And then finally, these two are going to add up here, and that's 53. So I just realized I missed out question number 11, but it's just popped up here now. So a developing mark, it's developing because it's a how many question. It's just getting you to pull a number out from the graph, and you should all be able to do that one there. But how many people, how many games did the Warriors win? So we can see the winning column is over here. So that means they won 53 games over there. So 53 games is what I'll be writing as my answer there. Question number 12, what is the probability of a randomly selected Warriors game being away? I do want to note this has gone from being how many over here to calculate the probability, and that's what shifts it up to an achieved level question. So remember, calculating the probability of an event, we always use, I told my class anyway to use the F over T approach. T stands for your total, like how many games in total were there, and in this case it's 117, and that's because all of these games were the games we're interested in. And of those 117, how many of them were away? And it was those 54 there. So that's going to be the top of my fraction. So if you can get 54 over 117, that's a pretty easy achieved mark there. Some of your teachers might have told you to convert that to a decimal. That's all good as well. And if you did that, you would have got 0.6415, and that there had a 4 dp rounding, but you didn't need to do that conversion. You would have got that achieved mark there. That developing mark is for someone who maybe had the table wrong and carried it into the question, something like that. So question number 13 now, what is the probability? So another probability, so we're going to be using our F over T fraction. What is the probability that a randomly selected game was at home and resulted in a win? So same thing, F over T, we already know the total, there's still 117 games. Of those 117, how many of them were home wins? That's going to be this number up here, right? 31. We don't care about the other numbers. So 31 out of 117. Again, that's enough to get your achieved mark, but some of you may put that into a decimal, and when I did that, I got 0.2650. That had a 4 dp rounding. Another thing to note is if you do have these fractions, you may be simplifying those fractions. That's all good as well. That would also get you full marks. So we're now up to the excellence question from the 2A tables, question number 14. This one here was a bit tricky. It actually is a bit similar to some questions that come up in the year 11 curriculum, but it's a bit dialed down to make it accessible for us. So, do the Warriors perform better at home games or away games? Your answer should be supported by conditional probabilities for home games and away games. So I've kind of dialed it down by basically telling you what to calculate. So I've told you to calculate conditional probabilities, specifically for home games and away games. So the first thing I need to care about, performing better in this context, probably relates to, winning in terms of the win-loss type stuff. So what we're going to do is we're going to find the probability that they won given they played at home. So that's the first thing I'm going to try to calculate. So the F over T approach we took in the previous questions is still valid, but now the totals change. I don't care about all of the games. I only care about the home games. So I only care about these 63 for this question. So that means my denominator over there is going to be 63. So of those 63 games, how many of them were wins? It was those 31. And that's the 31 we used from our previous question as well. So putting that into a decimal is really important for this question because you're going to need to compare these numbers, and it's really difficult to compare fractions, but a lot easier to compare decimals. So that's going to be 0.4921, and that had a 4 dp rounding. Okay, so I've done that for home games. I now need to repeat that for the away games. So what was the probability of winning given they were away? So probability of winning given they were away. And I just want to note, this stuff here is called notation. That's the way I'm doing it. As long as you're communicating what you're doing clearly, you can do other things, write it in a sentence, write it shorter, whatever it might be. So same process, F over T, favorable outcomes over total outcomes. The total outcomes now are changed. It's only the away games I care about. So it's only those 54 there. That's the bottom of my fraction. And of those 54 games, how many did they win? It was the 22 over there. So we've got 22. I'm going to put that in as a decimal, 0.4074, again for DP rounding. And just to note, by comparing these two fractions, it's difficult to know which one's actually bigger. You could probably take a stab at the top one, but you wouldn't be able to justify it too well. But comparing these decimals is really, really easy. And we can see it's about 9% difference. So that's quite a big difference, I think, in terms of NRL performance, to have a 9% change in your win ratio just by changing venue. Coaches probably need to look at that. So the Warriors win 9% more at home games compared with away games. So just to note, that was for my probabilities, but I haven't actually answered the question right. Do the Warriors perform better? So I need a clear statement about their performance. So because they're winning more, that probably means they're performing better, right? So I'm going to state that this suggests the Warriors perform better at home. So this suggests that the Warriors perform better at home. So we're now on to question 15 to 18, and this one here is on the dreaded probability trees. We went from two-way tables, which is the best done section of the exam normally, to probability trees, which is probably one of the worst done sections. So hopefully it's a way for you to get some marks when others may fall short. So question number 15, we've got a tree here, and this tree has come from a coach, and that coach has been tracking a pitcher's fastball or knuckleball, and we can see that split here. So the fastball happens 70% of the time, or 0.7 probability, and a knuckleball, whatever that is, 0.3 or 30%. He's partially completed this tree, so he's finished this branch here, but it looks like there's a bit of a gap here, so we'll have to deal with that later. So if he throws a fastball, he gets a strike 60% of the time, not a strike 40% of the time. The coach has noticed that the knuckleball is very effective, resulting in a strike 80% of the time. Complete the final branch of the probability tree. So that's doing exactly what I circled before then. So we're just going to split this up. So we're going to have our strike, and then we're going to have not a strike. And it said it was going to be 80%, so that's going to be a probability of 0.8. That means the probability there must be 0.2. So that there will get you your achieved mark. The next part, question number 16, if a pitcher throws 100 pitches, how many of them would you expect to be a fastball? So remember, your expected number is a giveaway. That's in your formula sheet. That formula is just N times P. N relates to the number of things you're investigating. We're investigating 100 pitches. So it's going to be 100 pitches. And then finally, P stands for probability, and that's related to the event you're calculating. And we know the probability of a fastball from the tree is 0.7. So that means there, if he threw it 100 times, 100 pitches, we would expect 70 fast balls, and that there is worth an achieved mark. The next question there, what is the probability that the next throw is a fastball and results in a strike? So fastball is over here, strike is over here, so we're trying to find the probability of this branch here, and hopefully you remember from class, to find the probability of a branch, you've got to multiply the two branches together. So we need to multiply 0.7 by 0.6 to get that answer. So the probability there is going to be 0.6 times by 0. I've written that the wrong way around, but 0.7 times by 0.6, and that there is equal to 0.42, and that there will get your achieved mark. And the very final question of the stats and probability section, it's a nice merit one. What's the probability that the next throw will not be a strike? And this one's a bit trickier than the previous question, that's why it's merit. So the previous one we only cared about one of the 4 branches. Now we need to care about 2 of them. So not a strike is over here, not a strike is over here. So we need to find these 2 probabilities here, and because it's asking you to consider both of them, you've got to add them up. So that first branch is going to be 0.27, so 0.7 times 0.4. So we're going to go 0.7 times by 0.4, and we're going to add on the second branch, which will be 0.3 times by 0.2. So we've got 0.3 times by 0.2. Again, I'm doing these in my head. Hopefully you're using a calculator. So we've got 0.28 plus 0.02, and that there is equal to 0.34. So about a third, slightly more, will result in not a strike in the next one. All right, so we're now into part D. This is the final and longer section of your exam. It's the algebra section. It's going to be quite academically challenging, but it's something that's going to be all good if you are prepared for this. So nothing's going to be a surprise. All the questions in this practice exam will have similar elements, similar vibes to the ones in the real exam, but you've got to be prepared for it. If you're just going to come in hoping to wing this algebra section, it's not going to go well for you. So let's get into question number 1, the first of the multi-choice section. So what is the highest common factor of 24 and 32? So we'll just do this one fully so you can see how it works. So highest common factor, factor relates to times tables. So what I'm going to do is I'm going to list everything that multiplies to 24. So 1 times 24 is the obvious, 2 times 12, 3 times 8, and then 4 times 6. So those are all the things multiplied to 24. I now need to repeat the same for 32. So it's going to be 1 times 32, 2 times 16, and then 4 times 8. So that was the factor part of the question. I now need to figure out, well, what do they have in common? So if I look at both lists, I'll circle them all. I can see they both have a 1 in common. They both have a 2. They both got a 4. They both got an 8 over there as well, right? They're the only numbers they have in common. And then now from the list, the answer is going to be the highest of these circled ones. So in this case there, it's going to be 8. We're now into question number 2, and this is a one that I really like putting in exams because it tests your knowledge. So we've got an equation over here, and you've been asked, well, what's the first step going to be? So remember, the goal in algebra when you're solving is that x there. You need to get it by itself, so that means the 3 needs to basically be moved to the other side, and so does that 5. So you've got to do them in the right order. So that's why I always ask you about the first step, because it really sorts out if you know what you're doing or if you don't. And the trick here is the negative 5 needs to go first. By moving it to the other side, you're basically doing its opposite, right, which is plussing of 5. So that means that the adding of 5 to both sides is the best step that you can take when solving that question. So number 3, 8 squares are needed to make up pattern number 1. How many squares are needed to make up pattern number 4? So if we had a fourth version of it over here, we can do that. So I guess the way to check is, when I got this diagram, I thought it was interesting, but I needed to clarify 8 because I suppose the first pattern actually has 9 squares, but we're excluding that one in the middle. It's the ones going around there that makes it 8 in total. So there's 8 over here. The next one here, there's 4 up there, 4 up there. So that makes 8, and then there's another 2 that makes 10, and another 2 that makes 12. And I can see it's got a plus 4. Just doing another one, so we've got 5 up here, 5 up here, and then we've got 3 here, 3 here, so that's going to make 16, and again, that's plus 4. So I know it's a linear pattern, so that means to get to the next pattern here, all I've got to do is plus 4 again, which is going to get me to 20. So my fourth pattern number 4, is going to have 20 squares kind of hidden up around the outside there. So question number 4 next, which of the following is not linear? So a linear pattern is one that has the same difference every time. So if we check out A, we can see, there to there, that's plus 3. We can see plus 3 again, plus 3, plus 3. So I know that first one is linear, so it's not going to be that one there. The next question there, we can see it goes, minus 2, then another minus 2, then another minus 2, then another minus 2. So it's got the same difference every time. So I know that's linear, so I can get rid of that. The second one is interesting. We got 3 and then 6 and then 12, then 24. So that change is different. So that means C is the actual answer. We'll double check with the last one and we can see plus 8, plus 8, plus 8, plus 8. That's all linear, so I know that wouldn't have been the answer. So C is the one that's not linear there. Now moving on to question number 5, a nice simple one. What's the coordinate of point A? And remember, when you're dealing with coordinates, it always goes x, y. So if you go down to the x-axis there, we can see that would have been 1, 2, 3, 4, and then we've got the 5 there. So my x value is going to be 1. So straight away, I actually already know the answer, because if you have a look down the x column, C is the only one that starts with a 1. But if you're wondering where the 4 came from, the 4 is, if you go across, we would have had 1, 2, 3, 4. So that means it would have been 1, 4, also confirming our answer of C. Okay, question number 6. What is the square root of 81? Hopefully you remember what the square root is. But the symbol you're looking for in the calculator is, you'll see one that looks a little bit like that. So you'll put your square root symbol in. You'll put it in 81. And what that's asking the calculator, it's asking is, what number times by itself gets you to 81? And when you do that in the calculator, you're going to get to 9. And just to recap, that's because 9 times 9 is 81. So the answer there would have been B. So we put some really common mistakes here. A lot of people think that's same as a divide by 2. So I've divided it by 2 there. And 9 plus 9 was 18. And C was just a random number that was in there. So if A is equal to -5, this is from question 7, and B is -2, what is A, B? So I guess the trick to this one, AB is going to be equal to A times B. So that means it's going to be -5 times by -2. And negative times a negative is positive. 5 times 2 is 10. That means it's going to be positive 10 over there. Now moving on to question number 8, and this is a really good one. I put these ones in every exam just to test if you know what you're on about again. So which of the following is not equivalent? So equivalent means it's the same number or the same expression. So basically the trick with these questions are you've got to simplify everything as much as you can. So the first question 4a, that's simplified already. A times 4, that there would simplify to 4a. We can see those match, which means the answer is going to be one of those other two, because there's going to be an odd one out. Number C, that's going to be 3a plus 4, because that 4 can't be added on to an a because it's not a like term. And the final one for completeness, that's 4a's all added together is just 4a. So straight away I can see A, B, and D, they're all equivalent to each other, which means the one that's not equivalent must be C. The next one here, number 9, form an expression for the following. So half an unknown number is decreased by 5. So I suppose the first thing to deal with is, the first thing from the question is half of an unknown number. So that could be a few things. It could be, 1/2 of n. It could be n over 2, that's also half, or it could be 0.5n. There's a few different ways we could have expressed a half. And straight away, that actually kind of gives us the answer, but we'll carry on a little bit more. And then it says it's then decreased by 5. So that's going to be, it could have been -5 there, -5 there, -5 there. And do we check if any of them match? It's going to be B over here. It's not going to be the top one because there's no need for brackets. C, the dividing is happening before the subtraction, and that's what would be wrong in C. And then D, I've just put it the wrong way around to there. So we've got B for the answer of that. Question number 10, a pretty hard achieved question, to be honest. It was quite rough, but hopefully it being in a multi-choice question made it a little bit easier. But form an equation for the following. So here we formed an expression. An equation, don't forget, is a bit of algebra equal to a bit of algebra, potentially a number. So we're trying to form one of those expressions twice, and we're going to set them, make them equal to each other. So the first thing, we've got 5 more. So straight away, 5 more, I know that's going to be something to do with a +5, then twice an unknown number. So twice an unknown number. It looks like all the unknown numbers here are being referred to as x. So an unknown number twice is going to be 2x. So part of my answer is going to be 2x plus 5. That must be equal to, so equal to. So straight away, I know it's not going to be C, and I know it's not going to be D. So it's got to be one of the other ones. So it's equal to the same unknown number decreased by 1. So that means it's, x minus 1, and then tripled. So the word then normally gives it away. That means there's some brackets there because you want the minusing 1 first, and then the tripling. So we're going to do our bracket. So the minusing 1 happens first, and then we do our triple, and that matches B. And the final multi-choice question, I've circled the achieve there, but number 11, what is the gradient of the given line? Gradient, I always form some triangles to help me with these gradient questions. So I'm just going to pick a few points that I can see clearly. So this point up here, I'll draw a big dot there. I can see that point really clearly, and I can see this point over here clearly too. I'm going to make a triangle with that, so I'm going to go down and then across. And from that, I'll be able to use my rise over run formula a bit easier. So my rise is the up and down movement, and this one's actually gone down -2. So my rise -2, my run is the bottom of the triangle there, and that's only run by 1 unit, so it'll be -2/1, which is just -2, and that works out well. That's one of the options, which is B. I've definitely noticed there's a lot of B's and C's in my answers. That's because I kind of did these multi-choice kind of randomly in my head, and people tend to naturally pick the ones in the middle. But just a note, in the real exam, we've done it through a random generator. That means there won't be an obvious BC pattern like we're seeing here. It'll be all over the show. It could be all A's or D's, a mixture of each, whatever. On to our next lot of questions. Question 12 to 14, and we've even told you what skill you need to use. You need to be using your substitution skills here. And for all of these questions, we know that R is equal to 6, S is -2, T is 4, and U is 3. And I suppose to emphasize, S is the only negative number there. So be careful with that anything has an S in it, because it's going to be a bit more difficult. And because I'm annoying and I want you to practice harder questions, I put an S in every single one of these. So they're not going to be easy, and there'll be some easier ones in your real exam, I think. So the first part of the question, RS, just a reminder, that means R times S, and then we go minus T. So let's do that. R times S is 6 times -2. So we've got 6 times by -2. We're minusing T, which is 4. So that's going to be -4. Simplifying that a little bit, that's going to be, what's that, -12 minus 4. And my final answer there, -16. And just to note, this line of working here, if you enter that in the calculator exactly as it is, that will get you straight to the answer. And that's something I encourage, particularly if there's lots of minus signs in your maths. Minus signs means you're going to make math errors, just everyone does it. So hopefully it's a way of minimizing and maximizing your mark. So there we go, we've got question number 13 next. We've got S outside a bracket. So as I said before, S is going to be -2, and then it's going to be T plus U. So T is 4 and U is 3. I can simplify that bracket. That's going to be -2 times by 7. And when I do that, the extra step, that there is going to get me to -14. So final one of the ones with S before we get into the messier one. Evaluate this. So we've got R squared first. So R squared, R is 6. So that means 6 squared is going to be on the top there. And then we've got S plus T down the bottom. So that's going to be -2 plus 4. I'm now going to simplify the top. 6 squared is 36. Over, I can simplify the bottom. -2 plus 4 is +2. And then I can do that division. 36 over 2 is 18 as your answer. And then, so just to note, most of these are merit and developing marks. Oh, sorry, achieved and developing marks. This one here is a merit one because I've put an X in here. We actually don't have X, so that actually means it's going to be an algebraic expression. You've got to simplify what you can. So we've got that annoying pesty S there again. So we've got -2, and then 2x is going to stay unchanged because we don't know what x is. R, we know what R is. That's going to be +6. And then we've been asked to minus TU. Don't forget that's T times U. So that'll be -4 times 3. So I've now got that, and I can now simplify what I've got here. So expanding the bracket's probably the best way to simplify all of this here. So we're going to have -4x minus 12, and then it'll be minus another 12. And that there will be -4x minus 24. So if you did the substitution up here, that's probably where your achieve mark came from. Fully simplifying it down there, that's probably where the merit was going to come from. So question number 16, we've been asked to match the expressions on the left to one of the expressions on the right. And it's saying, if you notice there's 4 over here and 6 over here, that means 2 of these options on this side here won't be matched at the end of it. We're only going to match 1 with 1. So I suppose the first question here, 5x minus x. A common mistake is people are going to delete the x's and write 5. That's the wrong answer. Just think about it. You've got 5 bananas and you're minusing 1 banana. That means you've got 5. That doesn't make sense. So it's 5x minus 1x. That's going to be 4x. So I can match this one here up with the one right next to it. So I'm going to draw some bold dots to make that connection more obvious. We've then got 5x divided by x. This is when the x's do cancel each other out. X divided by x cancels, leaving me with an answer of 5. So I can match this one up here with 5 down the bottom there. So I'm going to draw my dots and then connect them. I've then got x times x times x times x times x. That's going to be x to the power 5, because timesing x's together changes the power. And that one is actually right next to it again. And then finally, we've got x plus x, and so on. Adding all those x's together, that's 5x. That's the one at the very top. Those two there will be connected. And then these here will be unconnected. Just a reminder, if you try to connect 2 with 1, the teacher's just going to mark that wrong. So make sure you're only connecting 1 with 1. If you've got it wrong and you change your answer, just make sure the change is clearly crossed out, and then you put in your new answer afterwards. Okay, so we're now on to question number 17, and this is actually the big chunk of this exam. 17 to 31 is all about your miscellaneous skills. We can see simplifying, we can see expanding, we can see factorizing. On the next slide, there'll be some stuff about solving. These are your core algebra skills that you need to leave year 9 with. So question 17 is first, and we've been asked to simplify this, and this here is just an adding and subtracting question. So I'm just using my like term skills, and what's critical is I can only put the A together and I can only put the B together. I can never merge them to be an AB. So let's deal with the A's. So I've got 6A, and I'm looking directly in front of the 2A, because that actually makes it minus 2A. So 4A, I said 6A, but 4A minus 2A is going to be 2A. So that there will be equal to 2A. I can then deal with the B's. I've got 5B plus B. That there is going to be 6B. That there will get you an achieved mark. Most of this is new, so there won't be many developing marks in this section. We've then got the next part, simplify this. We've got M, N, and N. This one's going to be tricky. So the 4M, there's nothing we can do for that. So we're just going to leave it as 4M. But we've then got negative 3N minus 5N. So we've got negative 3 minus 5 is going to be negative 8. So that there is negative 8N. Down to question 19. Multiplying expressions now, and if you see with your adding and subtracting ones up the top here, we've got 2 separate parts to our answers. When you're multiplying, you're always going to end up with one part, because you can multiply anything together, but you can't add anything together. So when you're multiplying, your first step is to deal with the numbers. So let's do 5 times 6, that's 30. And then once you deal with the numbers, you deal with the letters alphabetically. So C is the first letter, so I'm just going to put a C next to it, and D is the letter after that, and I'll put down the D. So down to question 20, we've got some division happening over here. So we've got 55x squared divided by 5. So the letters are easy to deal with, right? There's only x squared, no other x's, we can't do anything with it. But we can do 55 divided by 5, which is 11. So this here will be 11x squared. 21, we're into the first merit question for this little chunk. We've got a heap of stuff being multiplied together. And we're going to follow a similar approach to question number 19. We're going to multiply the letters or the numbers together first. So let's do that. So we've got negative 4 times 5, that's negative 20, times by 2, that's negative 40. So we've got negative 40 there. We can now deal with all of the letters. So we deal with them alphabetically. We can see we've got 3 M's here, 1 M here. So that's going to make it M to the power of 4. Because it's multiplying, that's why the power is changing. Then we can deal with the P's. We've got 1 over here, 1 over here, 4 over here. That's going to be P to the power of 6. So 22 up the top, expanding. That's the rainbow method is how I described it to the classes I've taught this year. So we're going to start off by doing this times this, which is 12x squared. And then we've got this times this minus 4x. And because we're expanding, we're actually happy with that answer. We've gotten rid of the brackets, and that was our goal. Same question here, but this one's actually a merit one. We've got a whole bunch of brackets mixed up in here. We've actually got 2 sets. We've got a set over here, a set over here. We're going to expand them both separately, and then once we've expanded them separately, we can look to simplify using our skills from the previous ones. So let's expand separately first. We're going to do this times this. That there is 12c, and then we've got this times this. That there is going to be minus 3cd. I can now repeat over here, so that times that is d squared, so we're going to go plus d squared, and then we've got that times that plus 6cd, and we can simplify, think about what we can. So we've got a c here, whilst we've got c's over here and here, that's not a c by itself, so I can't merge anything with that 12c, so that 12c is going to stay the same, 12c. The same with the d squared. We've got some other d's, but we don't have another d squared, so that'll stay put. So I'm going to write plus d squared. But we've got some cd's, right? We've got negative 3cd here, 6cd here. combine that, that's going to be positive 3. So we're going to have plus 3CD. Getting all that right, that'll get you a merit mark. Just to note, I've got these in this order here. If yours are in a different order, that's 100% okay. You'll be getting full marks for that. Now to question 24, and the questions ask you to factorize. Remember, factorizing is the opposite of expanding. So expanding is getting rid of the brackets. Factorizing is bringing them back. So we need to think 12x and 18. Well, what is their highest common factor? What things do they have in common? They've got a 6 in common. So they actually had quite a bit in common. They both had a 2 in common. You can both divide them by 2, you can both divide them by 3, you can both divide them by 6, and we need to pick the highest of these numbers. That's why we've gone with the 6 instead of the 2 and the 3. So expanding was all about multiplying. So factorizing, being its opposite, is all about dividing. So what I'm going to do, this 12x, I need to divide it by the 6 that I've just talked about. So 12x divided by 6 is going to be 2x. Same thing over here, that 18, I need to divide that by 6. So negative 18 divided by 6 is going to be negative 3. And that there will be the expanded version of that 1 in 24. So 25, same thing, factorizing, you got to look for what they've got in common. And we can see they've actually got some letters in common now. So they've both got a P in common. So I'm going to need to take that out. And they've also got some numbers in common because 30 and 9, they're both in the 3 times tables, right? So that means they've got a 3 in common. So 3p is actually what's going to be in the brackets this time around. So I've got 3p bracket. Same thing as the last time. I need to go divide by 3p for that to work. So the p's will cancel. 30 divided by 3 is 10. So it's going to be 10q in the bracket. Same thing over there. Divide by 3p. The p's will cancel. 9 divided by 3 is still 3. So that there will be minus 3. So this factorizing stuff, pretty rough, pretty difficult. If you need help or support with it, let me know in the comments, and I've got a good video that I made during the COVID days that can support you and give you some extra help, and you can see some more examples done. So question number 26, this is a doozy of a factorizing question. That's why it's merit. So same thing, let's look what they've got in common. So they've both got numbers, and the highest common factor here is going to be the 6, because they can both be divided by 6. So I need to take out a 6. Let's look at the letters x squared and x. So they've definitely got some x's in common. So when they've both got letters in common, you're going to pick the smallest amount of x to take out. So I'm going to take out a single x over here. So I've got a single x. We then look at the letters. We can see we've got y cubed and y squared. Y squared is the smallest one there. So I'm going to take out a y squared. I can now do that division. So don't forget, I've got 6x squared y cubed divided by the thing I've got out the bracket. So the 6's would cancel each other out, right? Because 6 divided by 6 gone. We've got x squared divided by x. That will give us 1x left over. And then we've got y cubed divided by y squared. That will give us 1y left over. So xy is the beginning bit there. I'm then going to just write my minus sign in there. I can now do my 24x squared y divided by my 6x squared y. And this one looks messy, but it's actually quite easy. 24 divided by 6 is 4. So I put that down there. X divided by x, gone. Y squared divided by y squared, also gone. So I can close my bracket. That there would be my fully factorized response to that question. So now onto the next page, 27. We've hit the solving side of it, and this is probably really the only developing mark in this kind of chunk. We've got 5y equals 15. Remember, in algebra, we want to see the opposite, so you're not going to get any marks without opposites. So this 5 here, I need to move on over to the other side. The opposite of that 5, it's currently times 5, its opposite is divide by 5. So what I'm going to do is I'm going to go divide by 5 to this side here. So that will cancel out that, leaving me with y by itself. If I do something to one side, you can see my equal sign here. If I do it to one side, I've got to do it to the other side too. So I'm going to do a divide by 5 there. So 15 divided by 5 is 3 is my answer. So 28, solving. This one here is an achieve mark because there's 2 things. We can see the x over here at the top of the fraction there. So that means this 2 needs to go away and the 6 needs to go away. So you got to know which one to pick. And remember, when you're solving, you're doing BEDMAS backwards. So BEDMAS needs to be backwards. So it means addition and subtraction, that goes first. Multiplication and division, that goes next. Then your exponents, then your brackets. So we've got some addition and subtraction right here. That plus 6 needs to go. So I can get rid of that with its opposite. So the opposite of plus 6 is minus 6. So they would cancel, minus 6. So that leaves me with x over 2 is equal to 9. Opposite of a divide by 2. So fractions are just division. So the opposite of divide by 2 is a times 2. So those times 2's cancel. We've got that there. So x is equal to 18 in this case. The next achieve question, this one's got a bit of a trick to it. It looks fairly similar to the previous one, but it's got a slightly different. Do you see this time around the minus 8 is kind of inside the fraction? What that means is there's actually some invisible brackets on that top of that fraction. So we can't get to that 8 until the fraction is unlocked. The only way we can do that is by getting rid of the divide by 2. So there's no choice here really. We've just got to do the times 2 first. So that would cancel out that times 2. So it'll be x minus 8 equals to 14. And then that negative 8, I can now get rid of it. Opposite of the negative is a positive. So I'm going to go plus 8 to both sides. So those 8s will cancel out. So x will be equal to 22. So now into the merit one. You can see straight away this question looks a little bit different. All of these questions here, they've only got one letter and there's only one x in those questions. But here we can see we've got 7x and 4x. So what that means is before we get into our opposites, we've got to be thinking about simplifying the x's. And my strat for these that I've told all my classes is figure out which is smallest. So 4x is the smallest, and we're just trying to get rid of it. So the opposite of 4x is minus 4x. So 4x minus 4x is 0, so that would cancel out and it's gone. And we're going to do a minus 4x on the other side there. And now we simplify that. So 7x minus 4x is going to be 3x. The 15 plus 15 stays the same because we didn't do anything with that. And the minus 9 stays the same because we didn't do anything with that. But that 4x is gone on the right-hand side. Now this question here, now that I've eliminated, simplified the x's, that just is one of these two-step questions where you do your opposites. So we're going to do a minus 15 to both sides to get rid of that plus 15 first. So we've got 3x is equal to negative 24. And then I've got to divide by 3 to get rid of that times 3. Divide by 3. X is equal to negative 8. So now on to 31. This one's also merit because it's got two letters. So two y's over there. It's a bit easier because we're not having anything here, but it's also harder because this is locked away in a bracket. So the first step with these questions is just get rid of all your brackets by expanding. So that times that, 15y, that times that, minus 30, and that there is equal to 10y. So this question now resembles this question here. So your next step is to get rid of the smallest of the x's. So this 10x over here, also 10y, is the smallest. I can get rid of 10y by doing minus 10y to both sides. So that would go away. And we've got minus 10y over here. So 15y minus 10y is 5y. So we've got 5y minus 30 equals 2. This bit's a bit tricky if it's new to you. Those cancel each other out, so there's nothing left there. So that's why we put a 0. Now this question here is your two-step question. Don't get freaked out by 0. It's still a number. You can still deal with it. That's all good. So we're going to get rid of the minus 30 by doing plus 30. So we've got 5y equals to 30. And then we can do a divide by 5 to get rid of that times 5 as well, which means y is equal to 6. So we finished that kind of skills-based factorizing, simplifying, expanding, solving section. We're now up to the contextual part. And this is kind of the build-up of algebra because ultimately we want to apply algebra to contextual scenarios. So we need to know how it works to words. So questions 32 to 35 form an expression or an equation, depending on the question, from the context. So a drink costs us $4.50. A cookie costs us $3. Form an expression for the total cost of buying D drinks and C cookies. So this one here is easy. So we're going to go 4.5D. So that would find the total price of the drinks because you'd go 4.5 times the number of drinks. And then after that, you would add on the total cost of the cookies, and that there would be plus 3C because each cookie is $3. So you go $3 times by the number of cookies that I was going to buy. Do that. And to note, D and C, they're not like terms. So you cannot combine those. So you've got to leave it exactly as it is. Okay, so we're now on to 33. Get rid of that mouse again. So 30 number 3. This is an A-B question. I try not to do too many of these in exams, but we've got one here. So we've got a rectangle. It has sides of x, so 2x and x plus 5. So normally for these questions, I sketch my rectangle before I even do it. So I know the smaller side there, that's going to be 2x, which means that there has to be 2x, and that there is x plus 5, and that there is x plus 5 as well. So I've drawn my diagram, writing an expression for the perimeter of the rectangle. So the perimeter of a rectangle, or any shape with straight edges, is just adding together all the sides. So my answer here, it's going to be 2x plus 2x. That's the kind of the shorter sides there. And then I'm going to repeat the same with the x plus 5. So I'm going to go plus x plus 5, and then plus x plus 5. And I can simplify all of that. So we can see we've got 2x, 2x, x, x. All of that there is going to be 6x. And then after that, I've got 5 plus 5. That there is going to be 6x plus 10. So the next part of the question, well, if x is 7.5, what would the total perimeter be? And basically what that's trying to say is it's trying to say substitute 7.5 in for the x and then calculate the answer. So that there is going to be equal to 6 times by 7.5, and then you're going to add 10. When you do that, so you've got 7.5 times 2 is 15, and you've got 6, so that's times by 3, so that's 45. 45 plus 10 is 55. So 55 centimeters would be the perimeter of this particular rectangle. So moving on to 34, Morgan and Caleb both have the same part-time job. Last week, Caleb earned X dollars, Morgan earned X dollars, so we don't know how much money Morgan has earned. Caleb earned $20 more than Morgan. So Caleb's number would actually be x plus 20, right? If we had to think of it as an algebraic expression, it would have been what Morgan had, which was x, plus 20 bucks. If their total income for last week was $195, how much did Morgan earn? And then it says very clearly, to be awarded full marks, you must form an equation and solve it. So to articulate this a bit more generically, so we know from the question, total income of these two will be Morgan's income plus Caleb's income. So that's just a generic, easy way to do it. I can now start substituting in what I know. So I know the total income from the question, that was 145, so 195. So 195 will be equal to Morgan's income, which was x. So we're going to write x, and then we're going to add on Caleb's income, which was x plus 20. So we've got x plus 20. I can now do my simplifying before I move on to solving. So x plus x is going to be 2x. So that there means 195 will be equal to 2x plus 20. I can now do my opposite. So I've got minus 20, minus 20. So 175 is equal to 2x. And then I can do my divide by 2. And we've got x equals to $87.50. So that meant Morgan earned that much because Morgan was x, which means we've got the answer, so we don't need to figure out what Caleb has got. And I do want to note here, this stage here where I've circled, the x's are on the right-hand side. Don't stress about that. The x's can be anywhere, it doesn't matter. You're all sweet. So we're now on to number 35, and this here's the first of the excellence questions from the algebra section, and it was pretty rough. So the merit questions in solving were the ones with letters on both sides, which means the wordy version of that has got to be the excellent stuff. And there's an extra twist onto it as well. So at the movies, we've got an adult ticket costs $6 more than a child's ticket. So we might need to use that information later on. A family of 3 adults and 2 children pay the same as a group of 2 adults and 4 children. So what that's trying to say is, it's trying to say 3 adults, so we'll write this down here. 3 adults, we'll call it A, plus 2 children, call it C, is the same as 2 adults plus 4 children. So those two there are the same. The only issue is we've got A's and C's. That's not going to work for us. So we need to figure out what can we do to get rid of that. And that's where the underlined stuff at the top comes into play, because it said an adult ticket. So I'm going to write A up the top there. A is going to be equal to the children's ticket plus $6. So what it means is I can actually get rid of the A here. I can get rid of the A here, and I can put in C plus 6 instead. So that means it's going to be 3 bracket C plus 6. So you can see that and that is just the same thing, because adult is equal to C plus 6. And we're going to go plus 2C, so that's unchanged. And that's going to be equal to 2 bracket C plus 6. And then we've got plus C there as well. And again, same thing here. Your adult is equal to that as well. And now that I've got that, this is a lot better because I've got one equation, And there's only one letter, so C is the only letter here. So my first step is I need to simplify all the C's. So I'm going to expand all the brackets, I'm going to merge all the C's that I can, and then potentially try to eliminate one of them as well. So that times that, so that's going to be 3C, that times that, plus 18, and then plus 2C, that bit there's unchanged completely. That will be equal to that times that, so that's 2C, that times that, plus 12, and then plus 4C. All good. Now I can see the C's on both sides, there and there, those become 5C, so 5C plus 18, that must be equal to, we've got 2C, I've written an X down there, but that's meant to be a C, so that's going to be 6C plus 12. Now the stage we've got here, form the equation, I've expanded everything, that's exactly like the question we did in the previous section. We've got letters on both sides, we're going to target and focus on the smallest of the letters, so 5C is smallest. So I can get rid of that 5C by doing a minus 5C. So I've got 18 will be equal to C plus 12. And this question here has only got one thing to do, that's the minus 12, right? So minus 12, which means C is equal to 6. So we've solved for C. We just got to double check we've actually answered the question. Find the cost of one child ticket. Because it's an excellence question, I'm just going to put it in a short sentence. A child ticket costs $6. And that there should have the context needed to wrap up that full excellence mark. So we're now onto the last page. This is all the graph stuff. So straight line graphs are really, really important. You'll do a lot more of it in year 10, but hopefully this is going to get the foundation to succeed in year 10 as well. But question number 36, what is the gradient? So there's a few things we need to do. Gradient, x-intercept, and y-intercept of line A. And it clearly notes the x and y-intercepts should be stated as coordinates. So remember coordinates when it's like x, comma, y, and you've got the two numbers in there as well. So looking at number A, or line A, so let's do the gradient first. So gradients always rise over run. So we can see the point over there. I'm just trying to draw a bolder dot. There it is. And we can see the dot over there. And we can make a triangle. So there's my run, there's my rise. So it's 1 over 4, right? So my gradient, rise over run. My rise, that triangle's only going up 1 unit. The triangle's going across 4 units. So 1/4. Some of you may like to put it as 0.25. You're welcome to do that, but you don't really get any extra marks for that last stage. X-intercept, that's where the line hits the x-axis, and you'll see I've deliberately not given you an x or a y at the end of the axis to make sure you know which one's which. The way my class has been taught it, I always talk, y to the sky. So the one going up to the sky, that's the y-axis, which means this one down here is the x-axis, and we can see the line touches the the x-axis over there at 4. So that there will be 4, 0, because x is 4, and the opposite, y, will be 0. And the final bit of this one here, y is over there, y to the sky, -1 there. So that's going to be 0, -1. Again, so because it's the y-axis, the opposite one, x, must be 0. Okay, we're on to question number 37, and we've been asked to state the equation for line B. Use the form y equals mx plus c. This comes in your formula sheet if you ever forget it. But m relates to the gradient, c relates to the y-intercept. So we need to look at line B to find those out. So the easiest one to find is your y-intercept, which is going to be up there at 3. So that means from this graph, we know that y is equal to 3. The gradient is the next one you can figure out. And I can see a point there. So if I use my triangle from here to here, I can see it's gone down 2 and across 1. So my rise over run calculation for the gradient will be equal to -2, 1, or over 1, which is just -2. So my gradient here, m, in this case, m will be equal to -2. So that means my full equation, y, will be equal to -2x plus 3. And the next question, this one here is a merit one. It's actually quite a nice merit one, I think, if you know what you're doing. So question number 38, when does this line here, this is a new line, different from all the other ones, when does it intersect line B? Under line B, got rid of the other stuff, but line B is this one over here. So the way I would approach this one is you can use some fancy algebra to solve it, and you'll get full marks for that. I'm just going to draw this graph and have a look. So my start point on the y-axis is going to be -2. So that means my graph, this new one here, starts down there at -2. And 3 tells me it's got a gradient of 3, so that means my rise over run is 3 over 1. So that means it rises 3, runs 1. Rises 3, runs 1. So let's draw that in. So we're going to rise 3 and then run 1, so that point there. And that's actually the point of this question because that next dot is on that line we're looking for. So there's my point of intersection. But keep drawing it. We then can go rise another 3 across 1. So your line, hopefully you're going to do a better job with a ruler than I am, but you'll be connecting those points there. And that there would be a graph representing the equation y equals 3x minus 2. And as we're looking for the point of intersection, we can see that clearly. That was the point there, the first extra dot that we had to draw. The y and x are both 1, so that there would be 1, 1 would be that point of intersection. And you do need some working, and that's why I've drawn it on the graph to make sure I can show and demonstrate some working. And as I said, you could have done it algebraically, but that would have been a lot harder for the same effort. So look at the given pattern and answer your questions from 39 to 41. So this pattern here is quite nice. We can see it's a linear one, right? Because from there to there, that's plus 3.5. Then we've got another plus 3.5, another plus 3.5, and another plus 3.5. So we're adding on 3.5 each time. So the first question is, what are the 6th and 7th terms? We can see we've got 5 here. We've got term 1, term 2, term 3, term 4, term 5. So that means the next one is going to be 6. The one after that will be 7. So 17.5 plus 3.5, that's going to be 21. 21 plus 3.5 to get to the next, that's going to be 24.5. Question number 40, determine the nth term. So the nth term, remember, relates a little bit to the gradient that we've talked about. So the gradient, the rate of change here is 3.5. So it's going to be 3.5 n. And after that, you normally plus something. And that something comes from the number that would have been immediately before the pattern. So if I went backwards, it actually here would have been 0. So that means we're doing plus 0, technically. That looks a bit weird. So I'm just going to simplify that. So my final answer there will be 3.5 n. So we've done that achieve mark. That was a nice achieve mark too. Question 41, what is the 105th term? So what that means is n is equal to 105, because this list here, we're going to carry it on. We're going to go 6th, 7th, 8th, 9th, all the way up to 104th, 105th. So we need to find out what numbers in that 105th slot. So n is 105. We're going to put 105 into my nth term. So that's going to become 3.5 times 105. And when I did that on my calculator earlier, I got 367.5. So 367.5 would have been the number in the, if I carried on my pattern, in the 105th slot. Okay, so we're now up to the final column, so the very final 2 questions, including the last excellence question here. So we've got a spatial pattern below. We can see this here is a scenario for 1, and this here is a scenario for 2. And we can see this triangular thing, it's a table, and around the table we've got 6 people here. And that relates to the graph or the table that we've got here. So the number of tables, well, we've already calculated we're going to need 6 seats for that particular setup. Normally you get given the second one and then the third one, but this time around I didn't. I only gave you the 4th one, and it's your job to figure out the rest from that. So on the 4th one there, that's going to be this number down here. How many seats would there be? Well, there'd be 2 here. That makes 4. That makes 6. That makes 8. That makes 10. That makes 12. We're going to have 12 people, or 12 seats, or 12 people sitting around those tables for that. So we've got that there. We now need to figure out the pattern as to what's happening here. And this is where it's going to be a bit, kind of hit and miss to do. But the way I thought about this one was, table number 1, we had 2 here, right? 2 here and 2 here. If I drew it with 2 triangles together like that, we would have had 2 here, 2 here, 2 here, and 2 here. So that relates to the 6 that we've kind of got here. But what really is happening is we're just adding in these extra 2 over here. So that tells me, I'm thinking I have to add 2 people for every extra triangular table I get. So if I add on to 2, that there will get to 8. And if I add on to again, that there gets to 10. And if I add on to 2, that gets to the 12 I've already counted. So I've identified my pattern, I've double checked it with my other numbers. And then I suppose the final one, plus 2, that there had to be 14 if there were 5. So that's an interesting thing. You'll get an achieve mark there. That leads on to question number 43 really well, because question 43 by itself was too hard, but this helps you break down the algebra a bit easier. So we've got, for large events, tables and chairs are hired to avoid buying a significant number of each. Each table costs $150 to hire. So let's write that down. So table hire is $150, and then each chair is $15. So we'll go chair hire. That there's equal to $15. We've been told how many tables are set up for an event with a hiring cost totaling $3,660. So the way I thought about this question, the way I broke it down was, I knew that 150 times the number of tables, that there would be the cost attributed to hiring each of the tables. The chairs, well, that there would have been 15 times the number of chairs that you need, and that there combined would have got you to 3,660. So I've got all of that there. So I'm now thinking, how can I deal with this? Because I've got a T over here and I've got a C over here. I can only really do this if there's one letter. I've got two here, so it's going to be quite annoying. And this is where the nth term skill is going to come into play. So if I tried to calculate the number of chairs, the number of chairs would have been equal to the nth term. So that would have been 2t plus, and the number that would have been before the pattern would have been 4. So 2t plus 4. So the number of chairs you need is always equal to 2 times the number of tables you have plus 4. What I'm going to do is I'm going to take out that c and I'm going to put in 2t plus 4 instead. So that means I've got 150t plus 15. And again, the c is going away and 2t plus 4 is going in its place. And that there must be equal to 3,660. Now this is looking a lot better because I've got an equation, a question, and there's only one letter, t. There's two of them, so I need to simplify it, but I've got one letter left, so that's perfect. So I'm now going to expand. So that times that is the first step. So 150t, that times that there is 30t. And then we've got 15 times 4 is 60, and that there should be equal to 3,660. I can now simplify the t there. That's going to be 180, right? So we've got 180t plus 60 equals to 3,660. I can now start solving. My opposite of plus 60 is minus 60. So 180t is equal to 3,600. I took away the 60 from here, and I took it away from here as well. And the opposite of times by 180 is divide by 180. And when I do that, I get t is equal to 20. And that is actually the answer to the question. That tells you need 20 tables to have a hiring cost of $3,660. So because it's an excellence question, let's just put it in a short sentence to communicate my answer in context. So an event with 20 tables will cost $3,660. So that wraps up quite long, this video ended up being a lot longer than I intended it to be. That wraps up all of the 4 sections of your practice exam. Just a reminder, this is going to be really, really similar to your practice 1. Obviously the questions and numbers will be different. There'll be a slightly different mixture of skills, but if you're confident with the skills here, you're in a really good position for your end of your exam. So thanks heaps for watching. Keep an eye out for extra resources from your teacher to help you with this exam.